Welcome everybody. This is the Q&A for April 2022 for the Fundamental of Database Engineering course. We've been doing this for a few months now, and it's been very successful and very useful for people. And I believe it's always good to be like semi-interactive like this. So we receive a good amount of questions on this course because it became very popular, and it's only fair to pick one or two questions every month to answer them in depth. So I answer almost every question to my extent and to my time allocated, but some answers you can't just write. Just you need time to think about it and write about it. And some of them like deserve time like this and to explain it better, and this is one of them. So this comes from Dominique, and Dominique is asking about the implications of non-key column indexes in real-world database systems. Would it be best practice to create and drop new indexes with non-key columns for short-term purposes? Would this be a decision I make once they're setting up the table, when I launch a new application utilizing the table? And the second question is it really advisable to drop indexes of tables which might have various different use cases to different users? So here's what I want to say. The question will kind of relate to non-key indexes. It covers all type of indexes. Is it do you need some time to create indexes just for specific applications? Sure, you can create an index if you seen an app follows a query path that is not covered by an index. You might want to create an index to do that. The question is how often this app is executed, because the moment you add an index, you gotta go with the maintenance of the index. Well, the maintenance is not really that bad if you have like a few million rows, but if you go to multi-million rows and more than that, then index maintenance becomes really problematic. What I want to mention here is the real world implication of non-key indexes. So non-key column indexes are usually created when you have an index that is used in a query path. And that query path will efficiently use the index to get to collection of results. But then the query asks for certain columns that are obviously not in the index most of the time, right? If this collection that is returned is significantly large, then what the database has to do is take these keys that have been resulted, because we found the results set from the index. Now we have to go to the heap or to the clustered table and query to pull the full pages. And in a heap-based databases such as Postgres, where by default there is no clustering, what the index will do, it will say, okay, here are the pages that I need, because it knows that this index, this tuple belong to this page. So it needs to fetch all the pages in the heap and then pull these pages, and then from these pages it will take the columns it needs effectively, right, in addition to the things that is selected. And that is slow, right? Because you just use the index as a path to get to the rows. And if these things are random, and believe me, they will, because what you find is a bunch of tuples, right? And these tuples are all over the place. They're not as nicely ordered as in the index. They'll be all over the place. So you'll be querying all over the place. You'll be having a lot of random reads to the heap. And that is very expensive, and especially expensive in a clustered table where you're gonna do a B3 scans, right? Because on the primary key in order to fetch these pages or the results. So it is quite expensive to do that, man. Especially again, if it's one or two results, not big deal. But if you're fetching hundreds or thousands of results, then you're gonna see this random reads on the table, which translates to random IO, which obviously hits the disk and slows things down. You're probably gonna miss the cache, the OS cache and other caches in the process. So what you do is take the columns that you would have selected and recreate the index with those columns as non-key. This way, when you do your nice scan of the index, right, and you found the candidate rows, you didn't just find the candidate rows, you found all the columns you need in line in the index itself, which is very, very powerful. Now your query is done. It's an index only scan. You don't have to go back to the heap to do this random IOs, right? Or the primary key clustered index to do these random IOs. And your performance will be tripled, if not even more. Like, depending on the size of the results they're using. And then you might say, Hussein, I don't really return 10,000 results. You don't, but don't you have some queries that has select in select? And the inner select returns a lot of rows, but the outer select just picks one of them, right? And then return those. Some of these inner select queries can return a lot of rows. So if you can do these efficiently, you will have minimized the IOs. Right? So things that would have exacerbated the problem will be much, much isolated and minimized. So yeah, non-key is definitely, finally to close this, non-key indexes is that used in production all the time. I've been in this for 17 years and I always see non-key indexes in production systems. Yeah. It just makes sense. Yeah. What's the cost? There is always a cost to everything. The cost is space. And the cost is IO. Because now we're talking about B+3s, and if you're listening to this, you probably watched the whole course, which is good. So B+3 is everything in the leaf. So IOs now, you're gonna need more IOs to fetch the B3 lineage, the leaf trees. Is it a big deal? Nah, not necessarily. Yeah, it is. How bad it is, I wouldn't tell. I can't really tell you how bad it is. It's probably insignificant. But it is always a cost, right? And this is at the end of the day, you do a trial and error and see what's the cost of everything at the end of the day. All right, guys, very, very quick video today for the April 2022 Q&A. I'm going to see you in the next one. Goodbye.